4.0 diteruskan dengan pembentangan yang keempat. Majlis dengan ini menjemput Yang Dihormati Encik Tan Jeng Wei daripada Topcon Positioning Asia Malaysia Sdn Bhd bagi menyampaikan pembentangan dengan tajuk Sharing Knowledge of Emerging Technologies Introduction into 3D Laser Scanning for Building Information Modeling BIM Machine Control. Majlis dengan segala hormatnya mempersilakan.
Salam sejahtera and good morning to all the audience. My name is Tan, and first of all, I would like to thanks pihak CIDB for giving us a chance to take part in this meaningful event. Today, myself and my colleague, Mr. Chua Kok Seng, are representing our company Topcon to share our latest technology and solution. Right, so for today, the title of my presentation will be Introduction into 3D Laser Scanning for BIM. So before we dive into our topic today, let me introduce you with our company. We, Topcon, is actually from Japan, and our headquarters is located in Tokyo City. And we have been established in Malaysia for more than 30 years. And currently, our office is located in Glen Mary, Shah Alam. And not to mention, we are also the ASEAN regional hub currently to support both domestic and also the international business. Right. So in order to explain to you the benefit of our latest technology, 3D laser scanner, so let's talk about the evolution of the surveying instrument. Right. In surveying industry, there are two fundamental measurements. The first one is distance and the second one is direction. So the outcome of this measurement are X, Y, Z, which sometimes we call them as easting, northing, and also elevation. So in mathematical methods, normally we refer them as X, Y, and in survey method, we call them as easting, northing. Right? So as you might know, all our surveying data is measured by using the conventional currently in Malaysia. So there is a need for us to actually adapt to the new technology. Right? So all the modern surveying data measurement technique nowadays are based on this fundamental technique measurement that I mentioned earlier. As you can see, all of the picture here, which is the global navigation satellite system, laser scanner, and UAV or the drones, they are actually based on the fundamental to collect the survey data. These are some examples of the surveying data it could be. So they are terrain and also topography, right? So talking about the traditional surveying instrument, the common one we can see at the side usually is the level, which is the auto level, or sometimes people call them as a dumpy level. So it is used for height measurement, mostly. We use them to measure height difference between 2 points. While for the theodolite, we use them for the angle measurement. So the third one will be the EDM. For EDM, we use them to measure the distance, which we cannot measure by using theodolite. That is why we have total station at later recent year, right? So these are some examples of our instrument. This is for the level, the dumpy level. As you can see, it actually evolved from the tilting level and then to auto level, and the more advanced will be the digital level. And these are the example of theodolite. So this kind of theodolite is actually analog, which is a very old model. And for today, most people, they are using the digital type, which include the digital display. So for theodolite, we use them to measure angle. including the horizontal and also the vertical angle. When it comes to measure the distance, the user have to use either chain or tape to do the measurement. So it is very messy and time taking. So in order to solve all this hassle, we actually came up with the invention of EDM, and we install the EDM on top of the theodolite. And thanks to that, eventually we merged the EDM together with the theodolite, and it became a total station instrument. And by using the total station, we are able to measure angles and distance at one time. So this is the example of a total station, and it can do angle measurement, it can do distance measurement, and the accuracy can achieve up to 1 millimeter at 200 meters. And this is very precise for any site. And after the invention of total station, we actually have another new instrument, which is called GNSS. GNSS stands for Global Navigation Satellite System. It is a space-based radio positioning system, and it can provide user with high accurate position, which up to plus minus 2 millimeters, and also accurate velocity and time data. So for global navigation satellite system, we have many different type of satellite. For example, we have GPS, which is from USA, and we also have GLONASS from Russia, Galileo from Europe, and also the last one is Beidou in China. So this is the method that how we use the GNSS to do the survey at the site. Basically, we both have one base receiver, which stand on the non-point, and then the surveyor, they will control the rover receiver, and they will go and pick up the as-built data by using the common satellite. Okay, so all of these methods that I mentioned earlier, they are the conventional method, and by using them, they can become obsolete because they can only provide up to a certain accuracy, which after a stage in construction where it is definitely not enough anymore. So imagine that if, let's say, having to create the drawing showing a total station, how long it will take you, right? With all the advancement in technology, are our survey method in Malaysia adequate? And how do you think that they do the survey, for example, in Europe, Japan, or Australia? The answer is they use mass data collection survey instrument daily. These are only some of the examples that required nowadays 3D mass data solution. And how can we do data collection for this complex project by using all the conventional method that I mentioned, like theodolite or total station or GPS? The time required will be longer, and labor cost will be very expensive. Right. So these are also some of the example: roads, railways, bridge, tunnels, oil and gas facility, historical heritage. So now we come into the introduction to our laser scanner for BIM. So what is BIM? In short, BIM is an intelligent 3D model-based process that gives the AEC professional the insight and tools to more efficiently plan, design, construct, and even manage the building maintenance. So for vertical building, BIM can be involved in many aspects. For example, starting from construction, from the design, stimulation, and then for construction, as built, and after the building is finished constructing, we can use the BIM model to do the maintenance for the management, right? So let me share with you some of the traditional way and also the challenges we are facing currently. Right, the first one will be by using the conventional method, it is very least productive, and also we cannot ensure the quality. Sometimes the contractor, they provide low quality because there is no any inspection and no efficient inspection, I mean. And most of the time it required a lot of rework, and also it will eventually increase the cost of the construction, right? And also lack of coordination, because at the site everyone only based on the paper drawing. They do not access to any cloud system or whatever, so they cannot share the information at the first time. So this is the introduction of 3D laser scanning. It is a very new approach to collect 3D object data. So basically 3D laser scanning, we can use them to actually produce a very dense point cloud data. And the idea is it actually use a laser pulse from a transmitter to collect the measurement, which is the XYZ coordinate, by calculating the time differentiation. If you refer to this picture, you will have a better idea. Okay, and this technology normally can be found in mass data capturing instrument, for example, the terrestrial laser scanner, and also mobile mapping system, and also in any LiDAR application. So in summary, terrestrial laser scanner is actually more suitable for building facade and also some indoor 3D modeling. While for mobile mapping system, it is mounted on a vertical, and it is very highly effective to obtain 3D spatial information. For example, if you want to do a mapping for a country or even a city, you can use this application. The last one, LiDAR, is normally used for the large scale urban or suburban country mapping in order to create a DTM. So this is the example of the terrestrial laser scanner. So as what I explained just now, terrestrial laser scanner is more suitable for large structure and also for construction site. And for mobile mapping system, it is more into the GIS or mapping. Or sometimes if you want to do infrastructure maintenance, you can use mobile mapping system. Right? So this is an example by using total station and also laser scanner. So by using total station, you have to pick the point one by one. So it is very time consuming, and also it needed more labor. So in contrast, if you are using laser scanner, you only need one man, and all the information can be captured by one scan. And it is very dense data, which means you can access to any point, and surveyor, the user, that do not need to go back to the site and repeat to pick up the missing points. Right? So this is how it works. Basically, a laser scanner, it will spin 360 degree, and throughout the scan, it will collect all the points. So for this, we have a software which is called Magnet Collage. So this software is mainly used for the point cloud registration, right? So after we do the scanning by using the instrument, we need to do the registration. So we have terrestrial laser scanner, we have mobile mapping, we also have the UAS, which is a drone. So all these data we can actually combine by using this software, and we can export them into several formats. Like for example, the most common one will be large format, and also the E57 format, and also the PTS. So let me share with you some of the output that we did, our case study previously. So as you can see, this is actually example of a terrain with a heat map, heat indicator. And this is our another example which we conducted at Pajuta building. So it is 4-story, and we spent about 2 days, I think, to scan the whole building, and we did almost 100 scan station for this project. So eventually we extract the point cloud to become a 2D drawing to submit to our client. So these are the results we get by converting the point cloud into 2D drawing. And the next example will be the as-built point cloud that we took at the bridge Jalan Limboseng. So this is the result, and this is actually the point cloud data. So it actually is the combination of millions of points, and each point it carries the XYZ coordinate. So with the millions of points, we can actually calculate the length, I mean the height or whatever measurement inside the software, so the user do not need to go back to the site and pick up the point every time, right? And if you actually register with your reference, then we can also show the actual site coordinate inside the software. Like for example, if you see, we do the calculation from the top to the bottom, it is about 6 meters. The length is about 6 meters. All right. So the next example will be the pylon detail survey. So we use the scanner and we do the collection. We capture the data. If you look at this video, it can achieve up to 500 meters in vertical for scanning. Okay, so this is the extraction from the point cloud. Right, so the next one will be the preliminary survey and route mapping by using our mobile mapping system. So basically, we mount our laser scanner on top of a vehicle, and then we just drive slowly to capture the data. So it is not only capturing the point cloud, and in addition, it also captured the photo for inspection purpose. And eventually, we come up with we plot the utility mapping plan based on the point cloud data. Right. So now let's jump into the mass data solution. So I will talk about the as-built modeling and scan to being workflow in this section. Right. So in our company, we have 3 software solutions. The first one is H-Wise, and the second one will be variety, and the third one will be rhythm. For for H-wise, it is used for 3D model creation, and for variety, we use it for verification purpose, especially inspection. And for the third one, rhythm, we are using them to do the analysis on the concrete flatness and levelness. So this is our workflow. We actually collaborate with Autodesk to come up with this one. So from starting, the surveyor, they will collect the data by using the laser scanner, and then they will pass the data to the designer, right? So here we can actually imply our software solution, which is the H-wise, to make the 3D model automated in an automated way. And then the designer, they will pass back to the construction team. The construction team will base on the design to modify or to construct the building. And then when it comes to the inspection part, we can use our software, which is the Variety, to compare the as-built point cloud versus the design model. And also, not to mention, we can use the point cloud to do the floor, a slab, or whatever, a slab analysis. For example, the flatness and also the levelness. Right, now let me give you an example. Imagine that now we have a hotel building which built in 10 years ago, and all the drawing documentation is missing, but the owner wants to have a major renovate, and he wants a 3D model for future facility maintenance, right? So in this case, we can actually propose to apply laser scanning by scanning the building, and then we can obtain the as-built scan data, and then we can use H-wise to do the automated 3D modeling, which is this one, and then it will help us to create partial modeling, right? It will help us to create the partial modeling, and then we can export H-wise data into Revit to continue the further modeling. So this is one of the example here. It is a steel frame structure. We use our scanner to scan, and it takes about 19 location and about 5 hours time. So this is what it will look like in point cloud. And if you turn on the heat capacity, it will look something like this. Okay. Right. So when we import it into the H-wise, H-wise will help us to automatically generate the 3D model. And this is the 3D model that created by using H-wise. Okay. So this is another example, which is the piping, I believe. So it is a basement facility, and we scan by using our GLS 2000. And total, we have 8 stations for this project. And this is a point cloud. This is also the point cloud. Right? When we import into H-wise, it will help us to convert the point cloud to the 3D model, like what you've seen in this slide. But it is not fully converted. So the users still have to export the H-wise data into Revit, and then to finish up the modeling. But the main idea is H-wise can help us to speed up our modeling time. And this is the final result you will get in Revit. Okay. So let me show you a video. This is after we import the HY data into Revit, and we do the finishing based on the point cloud. So when we import the data from HYs into Revit, it will actually carries the intelligent. No, it is not a dummy model, but it actually carries all the intelligent, all the properties into Revit. Right. Now, talking about our second software, which is the Verity. It is a construction verification software where we use to compare the as-built point cloud with the design model, 3D design model. So it allows us to actually create reports and submit to our client by using this software. Right. So these are some introduction of this software. It is a companion tool for Naviswork, and it serves the purpose to compare the design, fabricated model to the as-built point cloud. And by using this software, we can actually reduce the costly rework and to prevent any major wrong installation, I would say. And eventually, we can also adjust the model into place against the point cloud to create the true as-built model. Okay. So this is the workflow. Basically, the surveyor, they will scan the site and then they will do the processing. And after that, they will only pass the data, the point cloud data, into to the BIM team to do the verification. Right. So this is how it works. It is a plugin for Naviswork, as I mentioned just now. So when we open up the Verity, you will see the point cloud and also your design model, and it will do the comparison. It will let us know whether this particular beam is within the tolerance. Let's say I set the tolerance as 100 millimeters. So it is within the tolerance, then of course it will show us this beam is actually passed. If it is more than 100 millimeters, it will show us that this particular beam is out of tolerance and we need to do something on it, right? So, like what you see now, this is actually our summary report that we can create by using our software. And you will see there are different colors because each color that represent different things. Like for example, the green one, it will represent the element is actually passed, and the red color, it means the point cloud doesn't exist, but your design model is there, meaning that it is not installed yet. So these are all the report that we can get. And if you refer to the picture, you will see a light blue color, which is the as-built model, and the purple color will be your design model. So we can calculate the differences in between these 2 points. So what are the benefits by using our construction verification workflow? So of course, we can control the quality, and also we can reduce the rework, and most importantly, we can increase the productivity and also decrease the risk at the same time. So coming to the last software that we have here is actually the Rhythm. So Rhythm is a companion tool for Naviswork as well, and we use it to analyze floor, wall, or even beam deviation. Not to mention, we can also produce the ASTM E1155 report by using this software. While the conventional method, normally they will use the deep stake survey, and it is very time consuming, and the user have to go to the site times by times to repeat the procedure. So by using our software, we can actually come up with a heat map, as you can see from this picture, and also the contour map. And for the workflow, it is the same. Surveyor will scan the site, and then we will do the registration, and then they will pass the data to the BIM team or the designer team to do the analysis. So by comparing the traditional floor flatness and the current challenges, reworks again, cost, quality control, and also productivity. Right, so, okay, I will skip this one. Right, and let me show you the last example I have here, which is, this is a warehouse that we scan by using our scanner. And then we actually spent about 48 minutes to scan all of them, and they are total in 8 stations. Right, if you can see, this is all the points, and then we actually transfer this point cloud data into Rhythm to come up with a heat map, and from here we can create the report and submit to our client. And we can actually play around with the figure as well. For this example, we actually using 0.01 meter, which convert to millimeters would be 10 millimeters. We can set as low as you want. We can do 1 millimeters, 2 millimeters, there's no problem. And for this one, this is actually the wall. We are using it to check the wall verticality. And as I mentioned just now, we can create the ASTM E1155 report by using this software. And these are the spec of the we follow lah. So like, for example, this is the report that we can generate. Normally, ASTM E1155, this kind of analysis is more to a super flat floor, super flat slab. And talk about the effect, of course, we can prevent rework, and then we reduce the risk, and we can control the quality, and also increase the productivity. So in short, 3D laser scanner is actually a more quicker and more detailed field to finish workflow than a conventional survey measurement, and we can always get the accurate result based on the point cloud. And of course, it is very reliable, and we actually imply to the survey grade accuracy. And the point cloud itself, it has many application. It depends on the user how they use the data, right? So for us, Topcon, we have BIM solution, and we offer them in 3 software, as I mentioned: HWise, Variety, and Rhythm. Right. So that is all from my part, and thank you for your attention. I would like to invite my colleague, Mr. Chua Koh Seng, to continue the further presentation.
Testing, testing. Testing, testing. Can hear? Testing, testing. 1, 2, 3. Good afternoon, ladies and gentlemen. My name is Chua from TopCon Positioning Asia. Again, thanks CIDB for having us here. All right. Okay, let me start with TopCon machine control history. All right. Over in the 90s, we have started our so-called business in 1994, and we started as a 2D machine control. Okay, so by end of 90s, we have started with 3D machine control system. So over the millennium, we have started our improvement and evolution. And last year, we have actually have our SiteLink 3D, which is a cloud management system, focused on performance monitoring of all the machine. All right. Okay, let me start with the session is what is machine control? Why use machine control and the benefit of machine control? And then the comparison between conventional and automated. Okay, for this current market situation, I think most of the participants know that now most of the things has increased. Equipment costs, labor costs, material costs, insurance costs, and in addition to the price fall of tender or bids. So eventually it leads to decrease of profit, as well as the number of skilled engineer is very difficult to find. Okay, to add on to the burden of the market situation, shortage of labor force is getting very serious. So these are the so-called news that we have gotten from the website. Okay, so as for example, the Malaysia Reserve has mentioned that Malaysia accumulating billion of losses on labor shortage. Malaysia faces manpower shortage in critical sector despite high employment rate. Okay, so Malaysia is seriously facing labor shortage. So construction business need to accelerate their investment in digital technology. Okay, so let me share with all of you what is machine control. Okay, so basically like what Tan has just shared with us, it consists of survey instruments. Our survey instruments consist of Hyper-VR, like using the GNSS, Global Satellite Navigation System, total station, and together with the hydraulic system. So this one, as you can see, is like the mini screen, like the mini iPad, where it attached to the cabin, so the operator can see the operation. And then we have a joystick for semi-automation, as well as the product like the main brain of the machine control system. So these are the sensor as well as the hydraulic system. So some of you might wondering, if I purchase a new machine, will it void the warranty? So my question is no, because we just do the bypass of the heavy equipment. Okay, so with the system from TopCon plus the heavy equipment from the construction site, such as motor grader, bulldozer, excavator, and milling machine. So by using our 3D design versus the reference level of benchmarking, so we will know what are the desired level for our cut and fill, or the desired level for the doing the so-called cutting for various application. Okay, so what can be controlled? So basically grader, dozer. Okay, so basically it can be semi-auto control the elevation, slope. For instance, I look at the diagram here. These are the so-called the 3D design data. So once the 3D design sent over to the operator by using the so-called the screen, the operator will do the operation automatically by doing the cut and fill. So these are the desired grade. Okay. So for excavator, it can also do sloping. Later I will share with you more of the benefit of using the machine control by using excavator. Okay, and then it can be controlled paver and milling machine. Okay. Okay, so this slide shown the difference between conventional as well as 3D machine control automation. So as most of you are aware, the conventional type operator need to be very skillful. Okay, so sometimes you need to spend much time and manpower for surveying setup, states. Okay, so you need a very skillful operator, especially when you handle motor grader, all right? And you need work together with the field personnel. Okay, so this will be taking longer time and expected when using the conventional type as compared to 3D MC automation. Okay, once you have the 3D design data, which like what Tan has just shared, it can automatically transfer to the screen of the so-called, like what we have seen, like the mini iPad lah, or the screen that the operator can see for doing the operation job, for doing the cut and fill. So basically for 3D machine control, you do not need stacking, and the result will be high quality, regardless of operator skill. If let's say the operator just operating the machine for 2 to 3 months, all the final grading job or all the final construction work will tend to fetch a higher quality work, all right? So eventually it increase the productivity and reduce the construction costs, okay? And work machine only in field. So you need less workers at the field. Eventually it will increase the safety for the construction job site. Okay, why use machine control? Okay, sorry. Okay. Okay, so basically on the top of the video here, it's shown that is using the eye construction. Okay, sorry, why I'm wondering just not working. Okay, so basically this is the working for eye construction. It only require machine working, all right, with less people on the field. Whereas as compared to this here, conventional, basically you need people like sticker to check the grading, everything, and sometime after the people do all the checking, then only the motor grader will tend to start their work after that. Okay, so these are the comparison table as for stack out. So basically for conventional, you need about basically this amount of time, 65 minutes with 4 workers, and 3D MC, no need. Adjust evaluation, you need about 53 minutes, 5 workers, whereas compared to 3D MC, you do not need it. Okay, so for survey checking, you need basically 6 workers, which this amount of time, whereas compared to 3D MC, you require about half an hour with 2 workers only. Okay, so these are the real case study we have obtained from overseas project. Okay, so eventually, all the process can be saved by 82%. So for this particular job application for model grading, grading work significantly can reduce 82% according to the conventional, because no need stack up work, you do not need adjust evaluation, and less check surface. Okay, so just imagine these are the only short case study within 2 to 3 hours. Imagine if you use it for daily, monthly, or yearly. So you can see the impact of the job site, how it can improve on the job efficiency, right? Okay, and this is, like I just mentioned, 3D MC can actually require less worker on the field, okay? So the operator can actually get the information they need in the form of display. Okay, so most of you might be wondering, is this very difficult to handle or to view or to understand? The answer is no. Through our experience, a normal worker, let's say Indon and Bangla, when they pick up some operation of excavator, they require a few weeks of so-called basic learning. Whereas compared to 3D MC system, it requires about 3 to 4 days to pick up the basic knowledge of the so-called the learning. Okay. Okay. So basically it says that it shows the location of the machine. Okay, it's kind of straightforward, and it have the left elevation and the right elevation. So these are the degree of the sloping. Say, so during the so-called operation, of course, we as a TOCON also provide our full support in order to ensure that the operator understand. So as long as the operator, like the so-called the Bangla or Indon worker, they know how to use a smartphone, this system should not be any problem for using it. Okay. So to add on, 3D MC can be used for night work as well, because it can be auto control function. So once the design data has sent to the operator side, which is the iPad, I mean the mini screen which appear at the operator side, all right? So they can just view and do all the auto control by using the cut, the required cut and fill, okay? Okay, so basically these are the benefit of using the 3D machine control and the 3D data. So I'm sure that during the previous presenter, Tan has shared with you the benefit of the 3D data. So basically from the surveying, 3D design, 3D MC, machine control, and 3D inspection, okay. So the process can optimize all construction process, okay, not only during the construction term, but also the surveying and design, okay. Okay, so I need to speed up another 1 minute, sorry. Okay. Okay, so these are the application for machine control. So basically for excavator, it can do digging and trenching. Okay, okay, so because of the time frame, let me just have a quick one on the automation for sloping. So we do have a machine control for excavator, mainly for doing sloping, and all we'll be doing on the semi-automate part. So it helps when you have a project for sloping at the dam or the open up the route for the hilly area, okay. And then for trenching under work, especially at the harbor. So if you have the 3D design data, you can do all the work, and then you know how deep that you actually doing the trenching work at the harbor or the riverside. Okay, this is the example that we just shown, which conventional, which is on the left. By using the machine control, you do not need the stakers or surveyor for doing all the so-called stack up. Okay, okay, so I will just skip. This is the machine control grading system. I will just skip. Okay, so okay, okay. So this is the compaction system, and also our intelligent compactor. Okay, these are basically our TopCon machine control lineup. We can attach to dozer, bulldozer, grader, excavator, milling machine, paver, and compaction. And the last is our site management with using the cloud management. So it can provide the remote support. For instance, if let's say your site is at outstation, the supervisor can monitor the workflow from the iPad or from the desktop at the office. Okay, it also can do the machine management, as-built, and truck management. Okay, so that's it for my session. Again, thanks a lot for your participant. Okay, now I will invite my colleague Tan for Q&A session.
Sharing mic kan?
Is it okay? One step. Okay.
I think this one's for me.
Okay.
Right. For the first question, traditional way still relevant or not? I believe you are mentioning about the traditional survey method, right? So the traditional way is still can be used, but like what I've shared just now, for the, let's say if you are using laser scanner and you can actually speed up your work, and also um, you can obtain more information and more precise data by using scanner, right? So yeah, that is it is good for us to adapt for a new technology, because slowly, of course, uh, you know, for BIM, it eventually will need laser scanner for us to adapt, right? Right. The second question, locally courses available where? Right. For this one, we actually BTopCon is actually working together with my BIM for current stage. I believe in future there will be one special module for this laser scanning. I believe it will come out by next year or sooner. And the third question will be, what about the horizontal construction by so far? Right, I believe this one is more related to machine control. Maybe I'll pass to Mr. Chua.
Horizontal. Okay. Actually, I do not really catch what the participant meant by horizontal by far. So probably I will just skip these questions. Yeah. Yeah. Next question, please.
Right, can we use 3D laser scanner for utility mapping, especially to map underground utility? The answer is, unfortunately, we cannot use it for map underground utility, because for laser scanning, the concept is it can only capture the whatever it is on the surface, right? Because we uses the laser scanning, laser point technology. That's why it cannot be penetrate over the wall or whatever, or below the floor, below the ground. And for your information, for map underground utility, we will use some kind of instrument, especially for that application, right? So in summary, laser scanning is more to upper ground and for building, right? And the next question will be, would like to know, is HWise only able to convert into 3D drawing? Can it convert into 2D drawing? Okay, this is a very good question. For HWise, it can only convert the point cloud to 3D model. And if let's say you are looking for 2D drawing solution, we do have it. It is another software, but I'm not presenting today. So feel free to reach us out, and we can do the further discussion with you. Yes, for your answer, point cloud can convert to 2D, but it's not using HWise. HWise is more to 3D model. And what is the percentage of accuracy tolerance? Right, what is the percentage of accuracy tolerance? If you are referring to HWise, for HWise, there is a function that we do actually need to go and QA, QC all the model. So in terms of accuracy, it depends on the user. If you feel that the pipes that created by the software is acceptable, then it is. And for the variety, we can actually set our own tolerance inside the software. Like what I shared just now, the example that I used is actually 100 millimeters tolerance. Right? So, okay, I believe there is no more further question. And lastly, we would like to thank perhaps CITB for giving us this chance to share the technology of ours. And Mr. Chua, do you want to have?
No, it's okay.
All right. So thank you so much and for your attention. See you in future. Thank you.
Thank you.
Majlis mengucapkan ribuan terima kasih kepada Encik Chua Kok Seng dan Encik Tan Jeng Wei atas pembentangan yang bermanfaat sebentar tadi. Majlis dengan ini dihentikan seketika bagi memberi laluan untuk berehat. Para peserta diminta untuk mengisi borang maklum balas dengan menekan ikon feedback di menu paparan skrin di atas. Semua peserta juga diminta untuk kembali semula bersama kami